Okay, so let's look at 3 examples here of where we use double angles to evaluate some things. We're given that the sine of x is 2/3, and then the cosine of y is 1 over radical 5. It's the same values we just used before, just being late in the previous example. But what that'll give us here is, if I want to just think about my triangles, if we make a triangle for x is an acute angle, we have the sine is 2/3, so 2, 3, and I think we found that that was radical 5, right? So that'll give us our, when we need x values, we can get the sine, cosine, and tangent all from right there. Okay, so for the sine of 2x, we would go to our formula sheet, we would look, and we say, oh, that's the sine, 2 times the sine of x times the cosine of x. As we look up here, the sine of x, well, we already know that was 2/3. So we have 2 times 2/3. And then the cosine of x would be the adjacent over the hypotenuse, would be radical 5 over 3. Then we multiply the 2 times the 2 times the radical 5. So that's 4 radical 5 over 9. It's rationalized. We're good. Nothing simplifies. That's it. Pretty quick to use those, really. For the cosine of 2y, now be careful because you're going to see these problems where it might switch variables, and it's really important. And if you're anything like me, you probably have a bad habit of changing everything into an x eventually if you keep writing long enough, because we've used x as variables so many times. We had 3 different formulas we could use. I still use the one I remember, which is going to be cosine squared x minus sine squared x. It would be a good exercise, though, to try one of the other ones and just make sure that it actually works as well. Oh, see, I already wrote x. So these will be y's. And let's see, here's our right triangle. There's our angle y. If the cosine is 1 over radical 5, I think we know that the opposite side would be 2. So for this one, the cosine of y, which we already knew, is 1 over radical 5 squared, which is great when you get to square a radical. And then from this triangle, we see that the sine would be 2 over radical 5. So minus 2 over radical 5 squared. Square both of them, so you get 1/5 minus 4/5, and that gives us negative 3/5. Now, something interesting to think about here is we don't know what x is. It's some angle, though, correct? But notice that when you doubled x, okay, so x, well, we assumed, I guess we assume that x and y are in the first quadrant. I probably should have stated that. That should be stated. We'll just generally assume that. But if you notice, x is some first quadrant angle, and when you double it, it's still positive. So maybe it's in the first quadrant, maybe it's in the second quadrant, right? But when you took it but y here, cosine was positive, right? But when you doubled the angle, now we get a negative value, which tells me this must have been something between like 0 and 90 degrees. But when you doubled it, you got negative, so it puts you in the second quadrant. Right? So it must have been, this y must have been bigger than 45 degrees, because when you doubled it, it moved you over into that second quadrant. Something you could think about there. And then our last example here is the tangent of 2x. So we're going to be back to this triangle again. And the formula for the tangent, double angle tangent, is 2 tangent x, 1 minus tangent squared x. Okay, so then if we look at this picture, we see the tangent is 2 over radical 5. So 2 times 2 over radical 5, and then 1 minus 2 over radical 5 squared. And then once we do that, I'm going to simplify the numerator. Is 4 over radical 5. The bottom is 1 minus 4 over 5, just 4/5. So then once we've done that, I'm going to leave that as 4 radical 5 for now. the denominator just becomes 1/5, correct? Oh, fraction divided by a fraction, I'm going to multiply by the reciprocal. So 4 radical 5 times 5 over 1 is 20 over radical 5. Okay, we're going to go ahead and rationalize. So 20 radical 5 over 5, right, and multiplied by radical 5 on top and bottom. Now here this is just one term on top, one term on bottom, so we can't cancel, and we get 4 times radical 5. So they're not terrible to apply. Sometimes, if you don't know the formula, it'd be tough, but I'm going to give you the formulas. You won't be expected to do those without the formula. So any questions? Anything? Okay. We all good? All right.